So today we'll be talking about the IP network basics. So the objective of this webinar is basically to educate you on IP in context of the PA topic. So the topics that we will touch today, as you see here on the slide, will mainly be IP network technology in general, what that means for a Presensa auto configuration of a network, the use of a DHCP server in Presensa networks, the role of DNS in a Presensa network, and what IT engineers need to know when they are setting up a Presensa system using DHCP. So as you see, this is actually a part of a bigger series of webinars. We already had the networking IP networking introduction. Now we will be talking about the IP networking basics, and through the course of the webinar, we will increase the level of complexity on the IP networks and talk about things like audio on IP, RSDP, hop count, real-time audio, security, and network requirements as well. But as mentioned, today we will be talking about the IP network basics. And as you see on the next slide, I will be hosting this today. So my name is Maarten Wings, marketing manager in EMEA. And today I'm supported here by Anton Thiele, who is application engineer for public address and voice alarm systems at Bosch. Okay, thank you, Anton, for supporting me today. You can take over and explain about the IP networking basics.
Okay, yeah, thank you, Maarten, for this introduction. Maybe to note also, if you can ask your questions at the end of the presentation by using the chat box function in the tool, and please then send it to all panelists. So that's something which you can take care of them. Let me start with the IP networking basics. Well, the Presensa IP networking basis is you need to know something about Ethernet to understand how to connect a Presensa system. Some of the things are that this technology, Ethernet technology, is something that's commonly used in local area networks. And a local area network is a network of computers and other electronic devices that covers a small area, such as a room, an office, or a building. Yeah. And you can also have wide area networks, which can span a large geographical area. So that's really on a wider area range. And this Ethernet protocol used is defined in the IEEE standard 802.3. And this describes how the physical connections are made between nodes or devices, such as routers, switches, and hubs via copper or fiber cables. So even the definition of such Cat5 connector is there defined. So the very basic on Ethernet is that an Ethernet is a frame. An Ethernet frame is like an envelope. So the IP packet is like the letter inside that envelope. So when you so an Ethernet frame is more or less the encapsulation around an IP packet. We normally talk a lot about IP, but that's the basic is actually the Ethernet frame, which is around that packet. So we always have it. That's the envelope, which is the first important thing. And switches manage these Ethernet frames. So they do nothing with IP, actually. So a switch must be quick. So they do not open that envelope. They only look where that frame came from and on which port, on which port it arrived and who should be the receiver. That's the basic function of a switch. So it's really a stupid device, but it just must be quick. So it means that it has then a table inside to understand where it came from and where it needs to go to. So if something comes back, that it immediately knows then, oh, that came from. So they have their own administration, their MAC address table, and with that they then know, oh, the next time I receive this frame, I know the last time it came from this port. So now I need to directly forward it to this port. So that's the intelligence which is inside the switch, but nothing more than that. So they don't know the receiver. They only, if they don't know the receiver, they send it out to all. So that's the first time when the first frame arrives and they don't have it in their administration, they just send it to all ports, and then the receiver will respond to it. But later on, when they have their administration, then they know more direct to send all the frames to the right ports. Yeah, that's a basic functionality of an Ethernet switch. And the content of the envelope, so the IP packet in a local area network, is only opened by the end receiver. So that's something. So so your PC will then open that envelope, or in this case, the PRAESENSA device will open the envelope to have a look into that packet. Yeah. Yeah, routers do open these envelopes. So an Ethernet switch does not, but a router will open the envelopes, the IP packets, to figure out who is the sender and receiver, and to transfer it to another network. So here, an example, you have here an Ethernet frame at the upper side, and from there, it is going then. So they throw away this route. This is a router here, this big block. The router will throw away the Ethernet frame, the envelope. It will throw away, and then it will pick out the IP packet, and that will be transferred through the router to another Ethernet network, and there it gets a new frame around, and then it can send again in that other subnet, for example. Yeah, that other VLAN. We come back to that later. And then from there it can again be reached. So that's really a physical separation, this router between the Ethernet side at the upper part of this picture and the side of the lower side of this picture. So are two different networks, we say. Yeah. So a router is a boundary of a local area network. Difference between VLANs and subnets. Subnets and VLANs are both partitioning the network. VLANs are on OSI layer 2, and subnets are on OSI layer 3, network layer 3. VLANs and subnets are fully independent, but common practice to create a one-to-one relationship. Yeah, that's important, this one, because there's a lot of confusion. We also here talk sometimes about subnets. We sometimes talk about VLANs, but what you normally do is that you have in one VLAN, you also define one subnet, yeah, to have these two aligned. But as you see, VLANs are on the layer 2. That means on the Ethernet level, on the frame level, and these subnets, that is a layer 3. That's more the IP packet level where you talk about. So, but you normally have them you can in principle yeah, you could mix it up, but we do as a common practice, we have a one-to-one relationship. So that means now for when you have these two together, purpose of a VLAN is to communicate with other devices in the same LAN. And for a subnet, the purpose is that has an IP address range of IP addresses, which helps hosts to communicate over routers. Right? So you see with IP, then that router comes into place. Yeah. Yeah, and LAN cannot scale infinitely. So because of all the broadcasts, I just told you, when a frame arrives on the switch, then the switch doesn't know where it should go to. It just sends to all. So yeah, if you have a lot of traffic going on here, and it will expand and expand, then you would also have a lot of traffic in that network. So it doesn't scale that good. Yeah, and in a subnet you can logically arrange a hierarchical architecture with that. So then you do not have everywhere that all the broadcasts will reach all the other devices. That's where we say these routers are really separators there. Yeah, for a VLAN, it can be configured on a switch. So all these different isolated Ethernet networks, they can be configured at the switch. A VLAN is nothing more than that you can split a switch into multiple switches. That's actually what you do. So you could also, instead of using VLANs, use a separate switch, for example. But yeah, that's sometimes not so practical. So so you can do with VLANs, you can create multiple switches inside a switch. Yeah, and then with the subnet, the separation is decided by the IP address. And when you look at the MAC addresses, so that's something which is using the Ethernet network. So that Ethernet frame is having a source address and a MAC and a destination MAC address. So that's really layer 2. And the MAC is the physical device of an Ethernet connection, which is unique. So that means that's the way how addressing is done in a VLAN. And in a subnet, or then we talk about the IP addressing, which is done on the OSI layer higher, where we really based on IP addresses have the source and the destination. So 2 different things, but many times they are used for the naming is used for the same. Routing, yeah, that's used then to break a large network into smaller IP subnets. That's also, I think, a little bit what I explained in the previous picture. But here we have then a router indicated which separates 2 subnets. On one side, it's then also a VLAN 1, and on the right side, it's a VLAN 2 defined. And so they are then in line with each other. Yeah, so that helps to make it easier to do your management for security and control. So, for example, you could use a router to separate particular racks in PRAESENSA in the future if you're using multi-subnet there, or when you have multiple PRAESENSA systems, you could have one at one VLAN, the other in another VLAN, and in that case, also separate each other, separate both them. So that could be the reason how to and then better manage the security with the proper, for example, firewalls or what you want to place in between. Control and limit broadcast and multicast traffic. That's also something what a router does. So especially control, as you know, or maybe not know, we are using a lot of multicast traffic in PRAESENSA, and that's that the reason for that, we come back into that in one of the next series, but I can shortly mention it is because of the fact that if you have an audio source, which for example does do an evacuation, and you then want to add, you have a phased evacuation, you want to add other amplifiers to it, yeah, then you must have a multicast stream to just add the next receivers to it. You cannot stop the evacuation and then start a new call and then make new lines there. So that's the reason why we are using multicast, to be really flexible in which different sources you have on which different destinations. Yeah. So, but yeah, a router can in this case control and limit this multicast traffic, but you need to organize it, of course. And segmented network is more fail-safe and scalable. I can already a little bit mentioned, but fail-safe means, yeah, when you have in one VLAN, you would have a device which is continuously broadcasting. Maybe it is defect, or you don't know what is happening, or so that can have influence on that section. If you now would have one large VLAN, it can influence the entire installation. So with this segmenting, it helps you isolating the part where that component has effect on. Yeah. So segmenting also from that perspective helps in making your installation more reliable. Yeah, a short part on IP addressing. It means that IP addresses have 2 parts defined by the net mask. So you have a network prefix, a host, and a host portion. For example, here, this is 192.168.10.100. You have then a net mask with 24 ones /24 of 2.5, 2.5, 2.50. And that means this kind of filter then has a logic with the IP address to say this is your network part. So everything what's one here at the net mask will then indicate your or this 245 digital 245.245.245.0 will then indicate here the network prefix, which is in this case then 192.168.10. That's your network. And then this part is your host. So you can have up to 255 addresses from the host. Yeah, of course, there is some restriction on the upper or the lower part where you need to have a gateway address. But so in principle, you have here these 255 range of your number of hosts which you could address. IP addresses in PRAESENSA, they are dynamically assigned. That means we do not, at least not yet, have IP assignment, a fixed IP assignment. That will come in the near future. But it has also advantages. That's why we initially really promote to use automatic IP assignment because of the fact that it avoids you to have IP conflicts in your network. So yeah, they are dynamically assigned at the moment. And if you do not have a DHCP server, then it will be an autoconfig network, and else you can control that through a DHCP server. So if that one is on the network, the DHCP server, then they will get the IP address from there. Yeah? So if there is no DHCP server, then PRAESENSA devices will, after power on, wait for 1 minute to get a DHCP server response. So they will wait if a DHCP server is online, especially when you boot the system, and then it gives also time for the DHCP server to become active. But if that's not there, then they will go into a link local address. So and that will then still make that unit reachable. So we do not need to have every time the same IP address for a component. Within PRAESENSA, we configure on the host name. So we do not configure on IP. We configure, so we talked now about a layer 2 or 3 on the OSI level. With PRAESENSA, we have a higher level, a higher layer in the OSI model where we have the names, where we have the host names of the devices. And that's the way how we how these devices communicate with each other. And that's actually also how normally every modern network is set up. We always have all PCs, and every host has a name. So we also, in this case, also from security perspective, we are using host names to communicate to our components. So the autoconfig network. So in case no DHCP server is there, so a link local is that method to assign IP addresses automatically when no mechanism of address configuration exists. And so there is no DHCP server, no fixed IP addresses are there, and no any other configuration method might have failed, then it goes into a link local. It's only valid within a local area network, so it does not go over routers, where a device is connected to. And these are the IP ranges, so it's 169.254.1 until 254.255. So you have a high number of addresses which you can assign in this link local range. Yeah? So that's just in case you do not have that DHCP server in place or fixed IP assignment. How does the procedure work? Well, a device is using an algorithm to allocate the IP addresses in that range, and they randomly select an address. So they just, and then ask if that address is already in use. It would be the same as if you walk with 20 people in one meeting room, and everyone shouts one name. My name is Anton, and anyone else here has this name? Okay. If not, then now this is my name. So if someone else would also call it already, yes, I am already there, then you would just make up another name. Yeah. So that's how this link local procedure also works. If the address is in use, the owner responds, and if no response, free to start using. That's how the principle of it. Yeah, all Dante and Omnio devices will use this link local if no DHCP server found. And in principle, it's standard network technology because also your PC does the same. So it's the only thing is that within the Bosch network, then we have they are blocked it to use link local on the PC side. But yeah, in a standard PC environment, it also jumps automatically to link local. Yeah? This is one of the key features that makes the Dante Omnio truly plug and play for a single subnet. So that's important to know where if you're in a single subnet, you can use this. Yeah, so the next one would be then using a DHCP server in Presenza. So that automatically assigns IP addresses to hosts and the configuration to configure the DHCP server to deliver host-specific configuration parameters. So for example, the pool, so that means the range of your IP address, and have it not overlapped with possibly fixed IP addresses. I've seen in the field people who set up DHCP pools which then overlap, for example, with a switch communication, which switch IP address, which was then fixed. So yeah, that kind of thing should be avoided, of course. But they have a free pool of IP addresses which such the HTTP server may use. Set the right subnet mask, the gateway to be able to reach the Presenza system from an external network. The DNS server can be entered and the DNS suffix. So the DHCP server application can be running on a managed switch or a server. That's normally where you have this application active. The principle works then, at the beginning, no devices have an IP address, so they only communicate through Ethernet, say it that way, so through Ethernet, what we talked about in the beginning. And then the client will send a discovery message. So an Ethernet frame will be sent out with a discovery. And then the DHCP server sends a unicast offer. So it will offer then, and then the client will respond with a request to say, okay, I want to use this DHCP server. You may provide me an address. And then the DHCP server completes the process with the acknowledge. And then with that process is then also an IP address provided. So this negotiation all goes via Ethernet and not over IP. After this process is finished, then the device has an IP address and then it can communicate. Then a short thing about the DNS in a Presenza network. Without DNS, we would need to navigate networks using IP addresses. What I just said, we are using names to communicate with our Presenza components. So that's why we also need to have then DNS. And using this domain names and then helps make system more to system much more user friendly. So you are not anymore related to IP addresses. Or for example, when you replace an amplifier, when you replace an amplifier, then so then you could just use the other host name of the other amplifier. And in that case, then you do not have to care anything about the IP address of that device. So if that gets another IP address, it doesn't matter. And the configuration is already the same. So it's then just a matter of selecting in your system configuration the host name of the new of the new amplifier, which is also displayed there. And so it's very straightforward then in replacing your devices. That would be the big advantage of using this principle. It's same. This DNS is actually the same. What a PC does to find an IP address, for example, to reach google.com. That's 8.8.8.8 if you put that in a web browser. But then you get to Google. But normally, then you use a DNS to figure out where, what the real name is. So DNS is a large and complex database. It's like a telephone book, and it's then used to resolve the IP address of the host given by the host and the domain where it is in. For example, that Google 8.8.8, and many often local DNS servers exist in a network. So also in your local area network, you can have, your company can have a local DNS server to assign names and the domain to your device. So a host name and a domain name together form that local IP address. For example, I could have here this is now a host name of a PRAESENSA system controller, which is part of the Bosch network, where we have our own DNS server in Bosch, where this is the host name. This the PRAESEL indicates a system controller. Then we have the last 6 digits of the MAC address -CTRL, and then after this the domain name is there, and then our local DHCP server in the Bosch network will assign this IP address to this system controller. Yeah, in case you do not have a DNS server in your network, or if you, for example, just set up a very small system with just locally on your desk with a system controller and an amplifier and a power supply, yeah, you do not connect it to the network. It's plug and play, yeah. So you can just look. You do not have to do any configuration there on your network out at the backside of the PRAESENSA. You just interconnect it, and so then you already create your local area network only on that PRAESENSA system. So it's at that moment it's really plug and play. But it still uses this DNS technology. But in this case, it's using multicast DNS. That means that the devices are not using an external DNS server, but they will keep track of it by themselves. So they have their own database then to know which devices are in the network, and they can then reach them through by names, by having this multicast DNS database. So that's something which then is still possible in case you do not have an external DNS server. It allows the device to learn the IP addresses from the other Delta Omnio devices, and this DNS database is then distributed across all devices in the local network. So all devices are in that case aware of which Omnio PRAESENSA components are in the network and how they can reach them. And PRAESENSA can resolve only any Omnio device using the device name .local in that case. So they can then change that back to resolve that to a real IP address. Yeah? So that's something which is then managed. So that means that this PRAESENSA, if it's a local system controller, might be a link local address of 169.254.12.54. So you can again only select this host name in that case, and by having that DNS with assignment on link local, you can then automatically, they know that to reach that host name through this IP address. That's all inside the device. Yeah, then you have the service discovery. Service discovery does not mean learning an IP address. Yes, you need to learn the IP address of a device, but this is just the beginning. Yeah, so you want to make connections using Omnio. If we want to make that using Omnio, we also need to know what on what port we should connect and find other Omnio enabled devices. So this is not only this service discovery is not only about this IP address linking to a host name. It's also about, for example, an amplifier. What can you do? What kind of services does it offer? Maybe you can send. So you have some more options there for these components to, and then also the controller knows how to interface and what they can do with it. So, but it's all based on standard network technology. Each PRAESENSA device is advertised themselves on a network using a service discovery mechanism. Yeah, so that's then something which happens there. That's then this DNS service discovery. It's in the past also used, for example, by simple or standard network printers, which are in your home Wi-Fi LAN. They will also use this type of technology to indicate what kind of services can be offered and can be done, and other applications know then what to, how to control it. Yeah? So the same technology is used within Presensa. My last part of this basics IP technology for Presensa for today is what the IT engineer needs to know to set up a DHCP to connect Presensa. So first of all, it is important to know in case you are connecting a Presensa system to a third-party network, what to consider. And this is very detailed explained in the installation manual of Presensa, chapter 4.6. So I would really recommend to have a look into that. And I think in many more sessions I come back to this chapter, because this is really the most important chapter for the IP networking part of Presensa. Another thing what you need to know is are the host names and MAC addresses of all Presensa devices. And there it is not so direct straightforward. That's why I here list them up and a little bit explain it to you. In the system controller, we have 2 MAC addresses or 2 host names. We have a device interface and we have a control interface. We have so this device interface, which does the audio, the routing, supervision, and firmware updates. That's also the device interface which you would see when you run the firmware upload tool. Yeah, so that's the one which is visible up there. But the system controller has a second interface. That's the control interface, and that one is used for the web page, but also for the open interface and for the logging application. And that's why you always need to add then to the original host name of for this example, 0B4866 MAC address at the end, you need to add the -CTRL, and then you reach the control interface. So yeah, so that's a separate MAC address which you then should be aware of. So network docent, that application will also show both. So there you can see it, how it looks like. You can see it on the labeling of the at the side of the unit. So there it's also mentioned, and in this way you can also obtain them. Yeah, you could ping to that particular host name, and then you can also see the IP addresses where you are connecting to. But yeah, so that is the way to obtain the MAC addresses, and you should know them also to when you want to set it up in a DHCP server for enterprise. Call stations also have 2 MAC addresses, host names. They have a device interface for audio routing, supervision, and firmware upgrades. So you will see that one. But it also has a GUI interface. So that means we have a separate control interface which manage the graphical user interface on the display of the call station. Yeah, so that's another one. Also, yeah, the labeling is also at the back of the unit, and you can also obtain that information through network docent, or even when you are connected through the GUI of the call station. Then you have the MPS, multifunction power supply. This one has only one MAC address. Same for the amplifier, and same for the ambient noise sensing. Yeah, so these are devices which also have an IP connection, and can in that case be part of your for the IP assignments. The internal domain, the DNS registration, the system controller host is then with that -CTRL. But when you have a look at the system composition page in Presensa, you can see then a drop-down list here with the host names which are shown here. So you can here also now then select the right host of your Praesensa system, yeah? And to in that way compose your system. So you do not here by yourself do any IP assignment, but that's something then which can yeah, based on the domain which you are using, you can then in the DHCP server and DNS server set this up. For example, again, that here we have a system controller with the in the Bosch domain, and then this DHCP server of the company could then assign that IP address to it. So then instead of using this URL, you could also use the IP address to reach it. But so it's just like standard IT technology to like you setting up laptops or anything else in your network. Yeah, you can also, if you have a redundant controller, there is a configuration called the group name. So you can then in your system configuration give your redundant controller group a host name. And in this case, for example, you call it system controller. In that case, this is the URL to reach that controller. System controller .eind.amea.bosch.com with a particular IP address. Yeah, and then you have always the group IP and the group name of the controller. You don't need to care about possible subcontrollers like this one or any other which you have assigned to it. No, this is then your the configuration. So also this this must be known by the IT engineer to set this up. Yeah. So because this is important to have here the clear overview, and we will have in the next sessions we go more into details on the network configuration and network setup. But I hope this already gives you a brief indication where to look at. So it's important that some devices have multiple MAC addresses, some have only single, but all these must be known for a DHCP server to have them assigned with a proper IP address. Yeah. But furthermore, then it's pretty straightforward. They will look for it, and when they find a DHCP server, then they get the proper information from there.
I would like to thank you for the participation, Anton. Thank you for the information and the webinar. For those who participated, as you saw, it's a webinar which is part of a bigger series. So please make sure that you're also joining the next series to get the full picture of the IP technology in the public address and voice alarm domain. And then I thank you for your attention and hope to see you on the next webinar.
Okay, then I'll thank you for your attention.
Okay, thank you very much. Bye bye.